Okay, Professor Jim Schultz here from my Finance 680 students. I wanted to go ahead and shoot another YouTube video for you guys, and I thought a good problem to go through here would be number 31 from Chapter 7 from the bond valuation homework set. And so let's go ahead and dive right into this problem. And so by this point, you guys may have already looked at my solutions, and so hopefully this isn't completely foreign to you. But let me go ahead and walk through kind of how I set this guy up. So let's talk about these timelines first and foremost. Okay, so the real meat of this problem is solving for the value of bond M, as in Mary. And you'll see why at the end of the problem. But most of your work here is solving for the value of bond M. Now, bond M is unique in that it basically has three separate, distinct payment streams over the course of its 20 years. For the first 6 years, it makes no payments. For the next 8 years, it makes $1,100 payments every 6 months. And then for the final 6 years, it makes $1,400 payments every 6 months. And so the way I did this, and this is not the only way that you could do this problem, but I like to do things in the simplest way possible, and to where it's nice and clearly defined and everything makes perfect sense to me. Setting these up in these three distinct timelines clearly shows me when things are occurring. You essentially have an $1,100 annuity right here, and you have a $1,400 annuity right here. So by looking at it that way, you can kind of break this thing into really manageable chunks and just handle each annuity separately and then add them up at the end. And so we're going to start with the middle one simply because it occurs before the last one. And so let's go ahead and knock this guy out. So you basically have a 16-period annuity, because remember we're making semi-annual payments over these 8 years. You have a 16-period annuity for $1,100. So you want to find the present value of that annuity. So we do that in the same way we would find the present value of any annuity. Set the future value equal to 0, plug in I, payment, and N, make sure they're on a semi-annual basis, and you get $13,817.21. Now, the hardest part of this problem, in my opinion, is remembering that this number is not in true present value form yet. True present value form is bringing everything back to 0 at the beginning of the problem. When you find this number, this 13,817.21, if you had to put that on the timeline, it would go right here. It would go at this 0, or at the beginning of this annuity. So to bring it from here to here, we have to bring it back 12 periods. And so that is why you see where I have written bring back to t equals 0. I got to bring this guy back 12 periods, right? And this is just, I treat it as a lump sum. The payments have already been accounted for. I do not have to insert those payments again. That would be double counting those payments. And then you find present value of that lump sum. So that's 9691.11. So that basically takes care of this middle segment of the bond. Now let's go to the last segment of the bond. We're going to do it the exact same way. So I'm going to find the present value of this annuity. Future value 0, I, payment, and N all must be semi-annual. 12 periods because it's 6 years. 12 semi-annual periods across those 6 years. You find the present value of $13,935.61. Again, if I was going to put this number on the timeline, it would go right here. So to go from here to here, I've got to bring it back 28 periods. I've got to go through this 16, and I've got to go through this 12. And so that's 28. That explains the 28 right here, and how we found the future value, or how we found the present value of this future value, $13,935.61. So there's your present value of the final 6-year annuity. And then you simply have, which I didn't mark on the timeline, you still have the $20,000 par payment coming at the very end that's still dangling out there. So you've got to find the present value of that guy. Future value $20,000, I is 3, payment is 0, N is 40. For I, payment, and N here, I maintained a semi-annual time frequency. I did that because the entire problem is on a semi-annual time frequency. That would be the most correct way to do this. If you saw that problem and decided to do it annually, technically that's not correct. But for you guys, this is an intro class at the grad level. I would not mark you down for that. And so if this doesn't quite make sense to you, then don't lose any sleep over that. I just wanted to maintain the consistencies throughout the rest of the problem. And in financial problems, that's typically what is done. That is the convention. So the present value of this $20,000 par payment is 61.31.14. So if you go up here for the bond M price, we simply add together the three present values that we found, and you get a total price of $21,913.18. That is the price of M. The price of N is very simple. N is zero coupon bond, essentially, with just one $20,000 par payment at the end. So this 61.31.14 that you found at the end of M, as in Mary, becomes the price of N, as in Nancy. And so that's why what I kind of alluded to at the beginning, where I said most of your work here is going to be solving for the price of bond M, as in Mary. And so this is how you solve number 31. I hope this is useful for you guys. This is definitely a very, very good problem to know how to handle really well.